All right, we're going to go over the remaining evens on section 6-2 before we do the odd ones for homework. Let's go to work. Looking at number 6, we already did 2 and 4, 2, 4, and 6 yesterday. So we're going to start at number 8. Okay, we are solving these quadratics using the quadratic formula. Number 8 already has a 3, but it's on the wrong side. So first thing I got to do is move it over. So I got to subtract 3 from both sides. So I now have 1/2 x squared plus 9x minus 3 equals 0. Now it's ready. Pythagorean theorem, quadratic formula, negative b plus or minus the square root, b squared minus 4ac all over 2a. So a, b, and c. So negative b, or opposite of b, would be negative 9 plus or minus the square root of 9 squared minus 4 times a, which is 1/2, times c, which is negative 3. Please don't forget the sign goes with it. All that over 2a. Plug it in, chug it out. Negative 9 plus or minus the square root. 9 squared is 81. Negative 4 times 1/2 is a negative 2. Negative 2 times negative 3 is a positive 6. All over 2 times 1/2 is 1. That over 1 makes it really simple, right? I can get rid of that over 1. So I'm now left with negative 9 plus or minus the square root of 87. Now, I told you that if that is not a perfect square underneath the radical, you can stop right there. How many people had that? It's okay if you had it over 1. Good job. Let's look at number 10. Number 10. Quickly, as I start on number 10, I can see this has to be moved over, so I need to add 25 to both sides. So I'm left with 2x squared minus 20x plus 50 equals 0. A, B, C. 20, negative b, plus or minus the square root of negative 20 squared minus 4 times 2 times 50 all over 2a, which is 2 times 2. Simplify. 20 plus or minus the square root. Negative 20 squared would be 400. 400 minus 4 times 2 is 8. 8 times 50 would be 400 all over 4. Okay, so 20 plus or minus the square root of 0 over 4. Well, square root of 0 is 0, so that's 20 plus or minus 0 over 4, or in other words, that's 20 over 4, which is 5. Now, this kind of really makes sense, doesn't it? Because what was my discriminant? What is my discriminant? It's 0. And anytime your discriminant is 0, how many solutions are you going to have? 1. And how many solutions do we have? 1. Hey. Amazing how this stuff goes together. That's awesome. Number 12, I believe is the last one on this side, correct? Number 12 is already in standard form for us, so it's ready to go. Negative b, or opposite of b. B is a negative 1. A is 6, and negative 1 is c as well. So I've got opposite of b, which would be 1, plus or minus the square root of negative 1 squared minus 4 times a, which is 6, times c, which is negative 1, all over 2 times a, or 6. So I got 1 plus or minus the square root of 1 plus, well, 4 times 6 is 24. Negative 24 times negative 1 is a positive 24, all over 12. So that's 1 plus or minus the square root of 25 over 12. Well, what's the square root of 25? 5. So I have 1 plus or minus 5 over 12. Well, in this case, I got 1 plus 5 is 6 over 12, which is 1/2. And then I got 1 minus 5, which is a negative 4 over 12, which is a negative 1/3. If it was a perfect square, we end up with tangible solutions that we like. If it's not, well, then we can leave it in radical form. Anybody get all those right? See your mistakes if you didn't. Okay. Last page. Remember, on the back, we are not using necessarily just the quadratic formula, but parts of it, to where we're going to find the x value of the vertex. And to do that, we use negative b over 2a, that portion of the quadratic formula. And then to find the number of zeros, we use a discriminant, which is b squared minus 4ac. So that's what we're doing here on the back side. Looking at number 18, first for my x value, negative b over 2a. I'm going to have 4 over 2 times 2, which is 4 over 4, or 1. For my discriminant, b squared minus 4ac, I end up with negative 4 squared minus 4 times 2 times 1. Well, negative 4 squared is 16. 4 times 2 is 8 times 1 is 8. So 16 minus 8 is 8. Now that I know my discriminant is 8, there are only 3 solutions. It can either be greater than 0, 2 solutions, equal to 0, 1 solution, or less than, greater than 0, equal to 0, or less than 0, and have no solution. Yes, ma'am.
In the other problems, how do you get rid of the square root sign?
And the ones on the front?
Yeah. I don't know. It's like the ones with the square roots. I don't know how to get them off the top and the bottom of the fraction.
I'll go back to that in a few minutes. So since this is positive, it's going to have 2 solutions. And that's what you're looking for. Question. Number 20. X is negative b over 2a. So in this case, that would be 1 over 2 times negative 1, which is 1 over negative 2, or negative 1/2. B squared minus 4ac, the discriminant, would be negative 1 squared minus 4 times negative 1 times 5. Everybody okay with where I'm getting these numbers? Anybody not okay? Okay, so now I've got 1. Negative 4 times negative 1 is a positive 4. Positive 4 times 5 is a positive 20. So 1 plus 20 is 21. Therefore, it's positive. I will have 2 solutions. Moving on, number 22. X is negative b over 2a. So it's negative 5 over 2 times 1, which is negative 5 halves. If you don't like improper fractions, it's also negative 2.5, but negative 5 halves is perfectly fine. Discriminant, b squared minus 4ac, is 5 squared minus 4 times 1 times negative 3. Well, 5 squared is 25. Negative 4 times negative 1 is negative 4. Negative 4 times negative 3 is a positive 12. 25 plus 12 is 37. Here it is again positive, therefore it has 2 solutions. Last one. X equals negative b over 2a. Therefore, it's negative 18 over 2 times 3, which is negative 18 over 6, which is negative 3. My b squared minus 4ac is 18 squared minus 4 times 3 times 1. I don't know what 18 squared is. Anybody? 18 squared, yes? 324. 4 times 3 is negative 12. Times 1 is negative 12, so that's minus 12. So that's 312, which is positive. Therefore, it has 2 solutions. Any questions on the back? The homework is to finish the odds. Finish all the odds and check your answers on the curriculum timeline.